Hello everyone, Miss Fogelman here for your math lesson. Let's get started. We're going to be doing number lines today. Alrighty, here are our slides. Okay, so today is October 7th and this is our math lesson. Our learning target for today is that the student will use a number line to show division by using repeated subtraction. Okay, so before we get started with our problem, I did want you to watch this short video.
Hi, my name's Julia. I'm going to show you division as repeated subtraction using a number line. So let's say we have a division problem like 6 divided by 2. 6 divided by 2. We're going to use a number line. We start 0 here and then 1, 2, 3, 4, 5, and 6. Let me number these. 1, 2, 3, 4, 5, 6. So if we're going to divide 6 by 2 on the number line, we start at 6 and we just repeatedly subtract 2 until we reach 0. If we have a remainder, then we would stop just short of 0 before we
You will not have to worry
completed
about
our
the
final
remainder.
2. But I picked a nice number, so we won't have any remainders. So we're going to subtract 2. There's a minus 2. We're going to subtract 2 again. There's a minus 2. And we subtract 2 again, and we hit 0. So we subtracted 2 3 times. So 6, and you take away 2 3 times, is the same as 6 divided by 2, giving us 3. Because think about it, division is asking you, how many times does this number fit into that one? We'll do another example. Let's say we did 6 divided by 3. 6 divided by 3. We'll start at 6, and this time we subtract 3 and see how many times it fits into 6. We go minus 3, and then minus 3. And there, dividing by 3 is the same as subtracting 3 twice. So 6 divided by 3 equals 2. And this is how division can be thought of as repeated subtraction. Thank you for watching.
Okay, so basically what she was saying, let me stop my share so I can grab my pen. All right, so basically what she was saying, where multiplication is repeated addition, division is repeated subtraction, because you're trying to figure out how many of one number fit inside another number. So let's start with this word problem we have here. Tracy rode her bike from Ellicott City, Maryland to Washington, D.C. She stopped for water every 7 miles. Okay, so we know that she stopped for water every 7 miles from the beginning to the end of her ride. She stopped a total of 5 times. And our question is, what is the distance that she rode her bike? So she basically went 7 miles 5 times. Okay, so there are 5 groups of 7, which is multiplication. 5 groups of 7. And we want to know how much that equals, and that will tell us how many miles she rode. Okay, so let's go ahead and draw our number line. You may do one at home too, or at school if you would like to do that. Okay, so we're jumping 7 miles 5 times. Okay? So we start at 0, obviously. This is one number line that will start at 0. And then we jump 7. So we're adding 7. Okay? Which leaves us with 7. Do not forget to put the jump and the number that you land on. We're going to jump another 7 because remember we have to do it how many times? 5 because she stopped every 7 miles 5 times. Okay, so 7 plus 7 is 14. Okay, and then we're going to jump again. So plus another 7. 7 plus 14 is 21. Then jump again. Another 7. We've done it 4 times now. We have one more jump to go. 7 plus 21 is 28. Okay, and then we jump again. Another 7. And we get 35. Okay, so 5 times 7 is 35, or she rode 35 miles. Okay, so we're going to put an M beside here because it's 35 miles. Okay, so let me review again. She stopped for water every 7 miles. So here's a stop for water, here's a stop for water, and so on. She did that 5 times. That's how we knew to jump 7 miles 5 times. So 5 times 7 is 35 miles. Now, this was a multiplication problem. Now we have to think, okay? Multiplication is repeated addition. So this is what our number line would look like. But if we go to the same problem, but written a little differently, let's go to the next slide. And then Ms. Fogelman needs to stop her share so she can get her pen back. All right. So now our problem is a little different. Now it says Tracy is planning a charity bike ride from Ellicott City, Maryland to Washington, D.C. Okay, so that part's the same. This time, though, they tell us that the distance is 35 miles, which we didn't know that information in the multiplication problem. Once the riders begin, there will be water stations every 7 miles along the route until the end of the ride. How many water stations will there be? Okay, so in this one, we know the total amount of miles and we know the number in each group because that 7 miles is the jumping. We do not know the number of groups, the number of times she stopped. So how will this number line look different than the first one? Okay, so let's look at our equation first. Our equation is we have a total of 35 miles. We're going to divide that by 7 because that we are given the number of miles they travel before the next water stop. So 35 divided by 7, and then the answer is going to be our number of times they stop. Now here's our number line again. Okay, but we have to think about how this will look different than the other one. Okay, so again, we have 0 here. And at the other end, we have 35. Okay, because it's a total of 35 miles. They're starting here and they're traveling 35 miles to the end. Okay, so this time we're going to subtract because we're starting with the total, whereas before we were starting at 0. So we need to subtract 7 until we get to 0. Do we know how many times we have to? I mean, we do, but we wouldn't know that if we hadn't seen the other problem. So we have to keep going until we get to 0. Okay, so 35 minus 7 is 28. Okay, we're not at 0 yet, so we've got to keep going. 28 minus 7 is 21. Okay, 21 minus 7 is 14. Okay, we're still not at 0 yet, so we've got to keep going. 14 minus 7 is 7, but we still have one more jump to do, and we're subtracting 7, and we're coming to 0. So now we're good, but how do we figure out what our answer is? Our answer is the number of jumps we did, not adding the numbers, but counting the number of jumps. So we have 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. So the number of water stations is 5. So how many jumps we made stands for the number of water stations. Okay, so our number line looks a little different depending on whether we're doing division or multiplication. All right, so let me erase that and we'll go on to the next slide. All right, so before we finish up today, I did want to do a review video of our 2's multiplication. See if it'll come up.
Yeah. Vocabulary. Do you know your 2's? Do you know your 2's? Do you know your 2's? Yeah, I know my 2's. Yeah, I know my 2's. Do you know your 2's? Do you know your 2's? Do you know your 2's? Yeah, I know my 2's. Yeah, I know my 2's. When you multiply by 2, you just double the number, that's what you do. You make the number twice as big. That's it, kid, just double it. 2 times 1 is cool, 'cause 2 times 1 is 2. 2 times 2 is more. 2 times 2 is 4. 2 times 3 is hip. 2 times 3 is 6. 2 times 4 is great. I mean, 2 times 4 is 8. 2 times 5, do it again. 2 times 5 is 10. 2 times 6 is doing well. 2 times 6 is 12. 2 times 7 is a party. 2 times 7 is 14. 2 times 8, fresh and clean. 2 times 8 is 16. 2 times 9 is amazing. 2 times 9 is 18. 2 times 10 is plenty, 'cause 2 times 10 is 20. That's cool. Now see if you can say the answer faster than we do. So get real fast, do the math, and don't let the rhyme go past. 2 times 8 is 16. And 2 times 4 is 8. 2 times 10 is 20. 2 times 3 is 6. 2 times 2 is 4. 2 times 6 is 12. 2 times 7 is 14. 2 times 9 is 18. 2 times 1 is 2. 2 times 5 is 10. Do you know your 2's? Do you know your 2's? Do you know your 2's? Yeah, I know my 2's. Yeah, I know my 2's. Do you know your 2's? Do you know your 2's? Do you know your 2's? Yeah, I know my 2's. Yeah, I know my 2's. Do you know your 2's? Do you know your?
All right, so make sure you're practicing those 2's multiplications, okay? and have a great day. Don't forget to get that work done.